In this video, we're going to be looking at achieved level modeling questions. So at achieved level, you are going to be given the model and you have to understand the parameters. So the coefficient of the trig function, it affects the amplitude, and this value here that's just being added on or subtracted is the mean value or the vertical shift. This value here, B, is the frequency, and it affects the period, and C is the horizontal shift. So it's important to understand that if there is a minus C, the graph is moving C units to the right, and if it's plus C, it's moving C units to the left. Okay. Now, so just to remind you, the distance from the mean value to the maximum is your amplitude. So the line right in the middle is your mean value. Here is your minimum. That is your maximum. The time taken for one full waveform to complete is the period, and period is 2 pi divided by b. And of course, if you rearrange this, b is going to be 2 pi divided by period. And it's always easier for you to realize that from the maximum to minimum is about half a cycle. So knowing that will help you in some questions. Okay, so let's look at an achieved level question. So in this question, you have been given the model and you have to answer some questions based on it. So it's very important to understand what X and Y represent. So X is the number of weeks since the start of the year, and Y is the average number of hours of sunshine per day. So from this function, we can figure out our mean value is 6.5 and the amplitude is 1.5, so the max will be 6.5 plus your amplitude, which is 8. Your minimum will be the mean takeaway amplitude, which is 5. Now let's look at the question. Find the average number of hours of sunshine per day during week 15. So X is the number of weeks since the start of the year, so 15 is our X value, and the question is asking us to work out what Y is when X is 15. So it's a straightforward substitution, and I'm going to show you how to do that on the calculator. Okay, so 1.5 times cos, and make sure your calculator is in radian mode, minus, I'm going to put brackets there, and X is 15, so I'm going to replace X with 15 there. Okay, so we get the answer 6.68, so that's all there is to it. Oops. Cool. Okay, the next question says, what is the maximum average number of hours of sunshine per day according to this model? We've already worked it out, so maximum is mean plus amplitude. The mean was 6.5 and amplitude is 1.5, so our maximum is 8. The next question, it says, during which week of the year was the average number of hours of sunshine per day a minimum? There are two ways you can work it out. One is by using a graph, and that's what I'm going to show you first. So let's roughly sketch the graph. So we have already figured out that the mean is 6.5. So that's the mean. And the max is 8. And the minimum is 5. So let's work out the period. So remember, period is 2 pi divided by b. And b in this question is pi over 26. So period equals 2 pi divided by pi over 26. So that works out to be 2 pi times 26 over pi, which is 52. So the period is 52. Now, if you look at the model, it's got x minus 3, which means there is a horizontal shift of 3 to the right. So I'm going to mark 3 here. The period is 52, so if you kind of think of the graph starting at 3, it's going to go 52 away from 3, so that will be 55. Now, it is a cosine graph, so cosine graph starts at the maximum value. So this is my rough sketch, and there we are, and I'll just extend the rest of the graph. Okay, now, the question is, during which week of the year was the average number of hours of sunshine per day a minimum? So this is the minimum. As you can see, it's halfway between 3 and 55. So it's about half a cycle from 3. So since the period is 52, half the cycle is 26. So we know that it is 3 plus 26, which is 29. So the answer is week 29. Another way we could have done this equation was by solving. So you could make y equal to the minimum, which is 5, and then solve for x. You could use your graphics calculator for that. So the next question, it says, find 2 weeks of the year when the average number of hours of sunshine per day was 6. So we're solving this equation here. Y is 6. Okay, so now what we're going to do is enter the right-hand side as one function and 6 as the other, and find the intersection point. So I'm going to show you how to do that using the graphics calculator. So in your graphs, if you have a graph already there, you just delete it. Okay, so now enter the function 1.5 cos bracket okay, now the other side is your second function. We're going to draw it. Now the view window, I'm going to make sure my x minimum is 0 and x max is 55. So we talked about y is 55 before, because there's the period is 52 and there's a 3 translation to the right. The minimum is y max and minimum. It's just about being able to see the graph. The max is 8, so I put a 9, and the minimum is 5. You can go with 4, but it was 0 and I just left it like that. Okay, so just use gsolve function, find the intersection point. So the first one is 18.8, and then you press your arrow mark to the right and it will give you the next one, which is 39.18. So first it asks for 2 weeks of the year when the average number of hours of sunshine is 6. So first one is week 19, and the second one is week 40. Okay, next question. How many weeks does it take for average number of hours of sunshine per day to increase from minimum average value to an average of 6.5 hours per day? Now, so we're talking about from minimum to there. So that is about quarter of a cycle. So all we need to do is 52 divided by 4, because 52 is a period, and that gives us 13. So it takes 13 weeks. And there we have it. So if you can answer these types of questions, then that's wonderful. You will be able to do the achieve level questions comfortably.